When we talk about finding limits, we also have to know how to find the limits of a function that involves absolute values. So what we always want to do is we always want to first turn our absolute value function into some kind of a piecewise function and then use that to find the limit. And we have looked at how to do that before. That's where we take the expression inside of the absolute value bars and set it equal to 0. So I have two examples with this. So looking at the first one, we want to find the limit if it exists and discuss the continuity. So first thing I'm going to do is I'm going to take that x minus 3 and I'm going to ask myself, when does x minus 3 equal 0? Actually, time out. What I should have done first is use direct substitution, but I did set up my problem. So if I do plug in 3, I get absolute value of 0 over 0, which is 0 over 0, which is indeterminate. So looking for another method, I'm going to go ahead and say, when does x minus 3 equal 0? Well, I know x minus 3 equals 0 if x is 3. So I know I'm going to break this function and say that the absolute value of x minus 3 over x minus 3 is equal to the function, I'm going to use a piecewise function, and something different is going to happen depending on what's happening if x is less than 3 and if x is greater than 3. So what I need to determine, so if I look at each piece individually, if x is less than 3, one of two things happen. If x is less than 3, either the absolute value of x minus 3 is the same thing as just saying x minus 3, or the absolute value of x minus 3 is equal to the opposite of x minus 3. So I can pick a couple test points to try. So let's say, for example, I picked x is 2. Well, if I plug 2 into the absolute value of x minus 3, I get the absolute value of negative 1, which is 1. Well, notice if I plug 2 into x minus 3, I get just negative 1. However, if I plug 2 into the opposite of x minus 3, 2 minus 3 is negative 1. The opposite of that is 1, and it is equal. Let's say I try another value that's less than 3, say 1. Well, when I plug 1 in, notice when I plug 1 into x minus 3, I get negative 2. When I plug it in here, I get absolute value of negative 2, which is 2. 2 is not equal to negative 2. If instead I jump down here, well, I already know that the absolute value of 1 minus 3 is 2. 1 minus 3 is negative 2. The opposite of that is 2. So I can say that this function here, if x is less than 3, is equal to taking the opposite of what I get when I do x minus 3, and I'm just going to go ahead and leave the bottom alone. If I do the same thing for if x is greater than 3, well, if x is greater than 3, I'm going to ask myself the same question. Is the absolute value of x minus 3 equal to x minus 3, or is the absolute value of x minus 3 equal to the opposite of x minus 3? Well, let's pick some test points. So x is greater than 3. So let's say I pick something like 4. 4 minus 3 is 1. Absolute value is 1. 4 minus 3 is also 1. Let's say I try 5. 5 minus 3 is 2. Absolute value is still 2. 5 minus 3 is 2. So it looks like as long as my values of 3 are greater, or excuse me, my values of x are greater than 3, that these absolute value bars are not necessary. So I can say that again, this function here is equivalent to, if x is greater than 3, just x minus 3 over x minus 3. So now I can go ahead and try to find my limit. So if I find my limit, as x gets closer and closer to 3, the only way my limit exists with piecewise functions is that the left-sided limit is the same as the right-sided limit. So I'm going to go ahead and say the limit as x approaches 3 from the left, is it equal to the limit as x approaches 3 from the right? Well, from the left would be using my top function, so I'm going to go ahead and use... So the limit as x approaches 3 from the left, if I'm looking from the left, couldn't I say that the limit as x approaches 3 from the left is of my function, but instead of writing absolute value of x minus 3, I'm going to write this here. Because I'm going to, if I'm coming from the left, I'm coming from values that are smaller than 3. So I'm going to choose this here, is negative x minus 3 over x minus 3. And I notice that I can do some canceling. That reduces, so I'm rewriting this function so I can use direct substitution, and I get the limit as x approaches 3 from the left is negative 1. Because that's all that's left of my function. I've turned it into a constant function. If I do the same thing and say the limit as x approaches 3 from the right, and I replace my absolute value function from my piecewise function, it's x minus 3 over x minus 3, I know that reduces to just 1. And x minus 3's cancel. And I get the limit as x approaches 3 from the right of the function 1 is just 1. It's a constant function. So right away, when it talks about discussing the limit, my limit does not exist because my left-sided limit is different from my right-sided limit. And as I said before, that's what I was checking to determine if I had that limit. So then if I'm discussing the continuity, I can also say this function is not continuous because it fails the second condition that says that the limit has to exist. And really, it even failed the first condition because I couldn't even plug 3 into this function. So the continuity fails all over the place. Let's look at another example with limits. If you want to pause the video and try it, there are only 2 examples. This would be a good one to pause and try. But I'm going to go ahead, and first thing I'm going to do is I'm going to change this into a piecewise function. So I'm going to change the absolute value of x plus 4. What is that equal to in terms of a piecewise function? Well, what is it equal to for x values less than 4? And what is it equal to for x values greater than 4? Well, for x values less than 4, if I plug values that are less than 4 into this, notice things like, for example, 3. 3 plus 4 is 7. Oh, I'm sorry. This needs to be negative 4 because it would be negative 4 that would make, remember, I'm looking for my cutoff to be what value makes the inside 0. I apologize. So that's why I want it to be negative 4. So I'm sorry. I'm going to pick values that are less than negative 4, say like negative 5. If I plug negative 5 into this, I get absolute value of negative 1, which is 1. Well, if I didn't have the absolute value, I would be getting the opposite of what I would get with the absolute value. If I plug in negative 6, because again, I'm wondering if x is less than 4, is it going to be equal to x plus 4 or the opposite of x plus 4? So, what does it have to be in order to make it equivalent to the absolute value of x plus 4? Well, if I plug in something like negative 6, negative 6 plus 4 is negative 2. I will not get that with the absolute value bars, but I will get negative 6 plus 4 is negative 2. The opposite of that is 2. So I'm going to go ahead and say that's the same thing as negative x plus 4, which leads me to believe, and I'll check, that if I plug in values larger than negative 4, I'm going to be able to use just this. So say, for example, I plug in negative 3. Negative 3 plus 4 is 1, which is the same result I would get with absolute value bars. Negative 2 plus 4 is 2, which is the same result I would get with absolute value bars. So it looks like this piece is going to just be x plus 4. So now if I look at the limit, as x approaches negative 4 from the left, I'm going to go ahead and choose this top one because left means I'm coming from values that are smaller than negative 4. And I'm going to have the negative x plus 4 over x plus 4. I know that's going to reduce, and it's going to leave me with the limit as x approaches negative 4 from the left of negative 1, which since it's a continuous function, or excuse me, since that's a constant function, it never changes no matter what I plug in, and I get negative 1. So the limit as I approach negative 4 from the left is negative 1. However, if I were asked to discuss the continuity, I can say that because a couple different reasons again, f of negative 4 is not defined, I get 0 over 0. Also, notice if I were to check the limit from the right, just for that extra practice with finding limits, if I were to check the limit from the right, then I would be going from values that are larger than negative 4, and I would use the function x plus 4 over x plus 4, which would reduce to the limit as x approaches negative 4 from the right of just 1, which would be 1. And again, I could say that the overall limit does not exist. Therefore, by condition 2, it is not continuous. However, if I'm only asking for the left, notice my left-sided limit is defined as negative 1.